So to get this in radical form, remember that the numerator is just like a regular exponent, but the denominator is always a root or a root, as some people say. I think they say that in the north. I have no idea. But you get the seventh root of m cubed, or m cubed inside of seventh root. You could also write it this way if you want. You could write the seventh root like that, and then you could do the m, and then like that's cubed. It just requires more writing. And if you don't put the parentheses, it just looks weird with the exponent floating, so I write it this way. This one, same thing. My resolution's a little foggy, but that is a negative power. So we want to write this. Here's what will be wrong. This is wrong. This is not negative y to the fourth and then cube rooted. A negative exponent does not mean it's negative. A negative exponent means reciprocal. So if you have negative 4/3 power, what that means it's the reciprocal of y to the 4/3 power. So that means you get 1 over y to the fourth inside of a cube root. Now this is the answer in radical form, but it does have an irrational denominator. So technically, we should rationalize this denominator. So even though this is correct, this is not in like radical form. Well, when we want to rationalize a denominator that has a cube root in the bottom, instead of like where we had in a square root, you only had to like multiply it by its own square root. For a cube root, you need like 3 copies of that thing to like turn it rational. So I got to put 2 more cube roots of y to the fourth. So the denominator becomes, this like breaks out of the cube root. The denominator becomes y to the fourth. The numerator becomes, let's see, there's 2 y to the fourths inside of a single cube root. So I can write that all as one cube root. And then it's really y to the eighth inside of a single cube root, like so. But I can simplify this radical. If you take 8 and you divide it by 3, that's 2 remainder 2. So that means there's a y squared outside, but there's also a y squared trapped inside, and that's all over y to the fourth. And then these y's reduce. So it's like there's 4 here, 2 here, 2 of them cancel out, so you end up getting 2 in the bottom. So you get cube root of y squared over a y squared, and those y squareds do not cancel out. This is your final answer. All right, for the next one, we're simplifying this expression, and you could really, honestly, you can just put this in your calculator. But if you're in a situation where you just want to simplify it quickly without depending on your calculator, picture this as the 3 denominator is a cube root. The negative 27 that's going to be to the second power. And since we're raising it to the second power, normally if you cube root a negative, you would get a negative. But since we're squaring, we know the answer will be positive. Now, I'm not going to do it in this order. I'm going to actually cube root it first. So even though it looks a little messy, it's actually more convenient mentally to cube root it first. So the cube root of that is, the cube root of that is 3. Negative 3 actually. But even if I goof up on the negative, if we square that, it becomes a positive, so you get 9. If you want to confirm in your calculator, and I think really it takes more time to type it in your calculator than it takes to actually do it. But if you do type it exactly as you see it with the parentheses, negative 27, raise it to the 2/3 power, you do get 9. All right, for the next one, this is 16 to the 3/4 power. And again, I think it's more convenient to do the root first and then the exponent next. So you could write that third power inside here, but the fourth root of 16 is 2. That way you're not dealing with a huge number. And then 2 to the third is 8. Really easy to do by hand. If you want to confirm using a calculator, you take 16 and you raise it to the 3/4 power. You can type it that way, or you can also type it 16 to the use alpha y equals. And in case you want to like see the 3/4 power look a little nicer, either way you get 8. But here's why I didn't do it the other way. Notice how we could have cubed the 16 first. Take 16 and cube it, and you get like this huge number. Then that number you have the fourth root, which just a reminder in case you ever need to use it. If you want to use high roots on your calculator, you go to Math, option 5, and it automatically fills in like this little thing. It's pulling whatever number you put in front of there. Number in front is this answer here, so I want to delete that. I want to do a fourth root, and I want to do a fourth root of 4096. You still get 8, but it's a lot better to do the root first, then the exponent, especially mentally, because you're not dealing with huge numbers. It's way easier. Okay, for our number 23, we're just adding like terms. Now, these are like terms, obviously, already. There's no reducing you need to do. It's just, hey, those are the same thing. There's 7 potatoes minus 3 potatoes. You're going to get 4 potatoes. And that's it. Don't try to like do anything with these exponents. Don't do 6th root or 9th root. Nothing happens with those. This is just like 7x minus 3x. 7x minus 3x is 4x. But instead of it just being x, it's this thing that's highlighted in yellow. Number 24 requires a little bit more work on our part because it looks like you can't combine it. So it looks like you're just stuck. It's like, oh, can't do anything. But you might be able to because you always need to reduce your radicals. You should do that every time. So if you look at 32, I know that 32 is divisible by 4. So that's 4 times 8, and 4 is a perfect square. But then 8 is also divisible by 4. So the 8 is 4 times 2. So really you get, if you simplify this radical, and you could prime factor it 2 to simplify, but this 2 is hanging out there. A 4 breaks outside the radical, and then the 2 is stuck inside the radical. So you get 8 times square root of 2. The x squared also makes it out, so there's like this x hanging out here. So we get 8x square root. And since you're squaring and square rooting something, like, you should put the absolute value symbols, but again, don't concern yourself too much if that's still an issue for you. But so it's 8 square root of x square root of 2. And I'm betting that when I reduce this 72, it's going to be, like, obviously this x breaks out. Okay, there's absolute values. And then there's 3 times, I'm pretty sure that this will reduce to something with a square root of 2. And in fact, if you take 72, you can prime factor it, or you could just do 36 times 2. 36 is a perfect square, so this is 6 square root of 2. So you got the 3 that's still hanging out there, and you got this 6, so that means that you have 18. So you got 8 absolute value square root of x times square root of 2 plus 18 absolute value of x square root of 2, which means altogether you have 26 of these absolute value of x square root of 2. And there's your final answer. All right, so the next one for 25, again, it looks like you can't combine them at all. It looks like you're just stuck, but we're not if we simplify. The cube root of 125, conveniently, this one actually is a perfect cube. That's 5. Now the cube root of x to the 6, if you take 6 and you divide it by 3, 6 divided by 3 is 2. So, and the fact that it's a cube root, like, you don't need to worry about even thinking about absolute values because it doesn't matter if you get, like, for one, the fact that, like, x is being squared, like, either way, this value is going to be positive. So putting absolute values makes no sense because since you're squaring it, the answer is going to be positive anyway. So it's not a concern. And for this, 27, you should memorize that the cube root of 27 is 3. You shouldn't even have to use a calculator. But if you do, I mean, you're allowed to use it. That's great. It's just, burns a little time, but it's fine. And just another review, if you want to do cube roots, yes, you can use the Math 5 button and put a 3 there. But if you use Math and do 4, that one does cube roots a little bit faster. And another thing you can do, I don't like to use that button at all. If I want to do a cube root, I'll raise something to the 1/3 power. Same thing with 125. I raise it to the 1/3 power. I just find that more convenient than having to go to that Math button. So you got 5x squared minus 3x squared. Simplify that, becomes 2x squared. And there's your final answer. You can't, the numerical parts you can do in your calculator, but remember the variable parts, there's no way to do those variable parts in your calculator. If you try to put cube root of x to the 6th power, it will not tell you x squared. Watch what happens when I try to put it. Thing is, and you'll get a different answer if you do it in your calculator. I have some value stored in place of x. It's going to try to calculate it. It doesn't read these as variables. It reads letters you put in as numbers. So it won't work out. Don't try to do that in your calculator. You have to understand the properties for those. So that's 25. All right, for 26, I'm having trouble with this, so I'm going to try to rewrite it in exponential form. 7 to the 1/4 minus 7 to the 1/3, and see if that helps me. Well, normally that would be a help, but here's the thing, I'm subtracting. There's nothing to do here. These are unlike terms. I can't combine them. Now, if it was 7 to the 1/4 power times 7 to the 1/3 power, guess what? I could add those exponents, and then that would work. If it was 7 to the 1/4 power divided by 7 to the 1/3 power, I could subtract those exponents. But that's not what we're given here. These are unlike terms. The answer is this cannot even be simplified. So you just can't do anything. So the answer is just nope, can't do anything, done. The simplified version of this is the original problem itself. For 27, we're just going to use the distributive property. So square root of y times square root of y is just y. Do square root of y times 2 square root of 3. That's going to be 2 square root of 3y. Let me color code that. I can put them both under the same radical because, you know, a radical times a radical is, the index is the same. So I can put those like that. And I'm going to distribute this right here. That's going to be minus square root of 3y. And then this last one right here, this is going to be, let me just put my work off on the side. I know it's going to be negative, but it's 2 square root of 3, that's this right here, times another square root of 3. Well, square root of 3 times square root of 3 is just 3. Or you can say square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. So we get 2 times 3. 2 times 3 is 6. So minus 6. Now, it might seem like nothing else combines, but here's the thing. This is 2 square root of 3y. This is minus, there's like an invisible 1 right here. Minus 1 square root of 3y. So it's y. Plus, there's 1 square root of 3y. Minus 6. And that's your final answer. You could optionally, if you want, you could put a 1 right there. You know, the little Abby one, as I say. But it's not necessary to put that 1, so it's completely up to you. All right, for this one, you have two options. You can use this as a reciprocal first, like a negative exponent as a reciprocal. Remember, it is not a negative value. The answer to this is not negative. So don't go thinking a negative exponent means negative value. They're not related at all. I'm going to distribute the exponent. So I'm going to distribute the fourth power to this term. I'm going to distribute the fourth power to this term. You also have to distribute the fourth power to the little coefficient there. So we do raise 16 to the negative fourth power. And then we also take x to the 1/4 and we raise that to the negative fourth power. And we take y to the 3/4 and we raise that to the negative fourth power. Now the exponent, it's fair to everyone. It raises everyone to the negative fourth power, but for exponents, you do a little shortcut. Multiply these, you know, the 4's cancel out. 3/4 times negative 4 comes out to a negative 1. 1/4 times negative 4 comes out to, that comes out to a negative 3 for the y, a negative 1 for the x, because the 4's cancel out again. And then whatever 16 to the negative fourths is, I'll use a calculator for that. Or I could leave it in exponential form. But the idea is I'm going to take these values. Wait, these are all negative exponents. We don't like to leave negative exponents in our answer. So what does a negative exponent really mean? Well, it means reciprocal. So this 16/4 to the fourth power goes on the bottom. This x to the first power also goes on the bottom. And notice how I can put the 1 if I want, but it's not necessary. You don't have to if you don't want to. It's not wrong to put it. No, y to the third power goes on the bottom. So this is my answer. If I want, I would perfectly be fine if you just left that as 16 to the fourth power in the bottom. If you want to go through and calculate it using your calculator, there's nothing wrong with that. It's 1 over 65,536 x, y cubed, like that. For 29, again, just like it distributes over multiplication, also distributes over addition. So this gets the 9th power, and then so does this. So if you do x to the 1/3 power, the shortcut is to multiply the exponents. If it helps to write it as 9/1, you can do that. And then y to the 2/3 power. When you're raising a power to a power, again, you multiply the exponents for the shortcut. And so this becomes x to the 3rd on top. And then this becomes, see this cancels out 1 and 3, 2 times 3 is 6, becomes y to the 6 on the bottom. So you get x to the 3rd over y to the 6th. For number 30, I'm going to work two ways. So I'm going to take one path, and then I'm going to take a different path to show you that there's two options. You can choose to distribute first and then simplify. So that would be like if you take x to the -10th. Remember, the shortcut is to multiply the powers. And then you could take x to the 5th. The shortcut is to multiply the powers because that power distributes, because the parentheses means it applies to the top and the bottom. So here the 5's cancel out. You get x squared on bottom. Here 5 and 10 cancel out to 2 and 1, so you get x -4th. And then when you're dividing, the shortcut is to subtract the exponents. So you take x to the -4th minus 2, so you get x to the -6th power, but we don't like to leave negatives in our final answer, so you get 1 over x to the 6th. You don't want to leave negative exponents in your final answer. Okay, I said this was the distribute then simplify method. That's the blue path here. Let's do, what about if we simplify first then distribute? So if I do the little subtraction shortcut quotient rule first, if I take x to the -10th and subtract 5, notice how I get, and then all that is eventually raised to the 2/5. So this is x to the -15th power raised to the 2/5. All right, and then what I can do is really this splits up into two paths possibly, but let's say I do the shortcut where I multiply the exponents. So x to the -15th power, you take -15 and multiply by 2/5. This cancels out to a 3 and a 1. You still get x to the -6, which still comes over at 1 over x to the 6. So there's more than one way to do that. And even right here, you could have gone further. Like you could have said, hey, this negative exponent, that's 1 over x to the 15th, but we still need to raise it to the 2/5 power. You're still eventually going to get 1 over x to the 6. So no matter what way you do it, you just need to apply the quotient rule for exponents, subtract the powers, and the raising a power to a power rule where you multiply the exponents. Either order you do it in will get you the same. For 31, we're given an equation that relates area to radius. And by the way, where this comes from is a equals pi r squared. If you solve for radius, you have to divide by pi and then square root both sides. But we're just asked to calculate the radius when given the area. So use this formula. So we got our radius is equal to the square root of, well, the area is given as 169 pi. You have to leave that pi in there, so 169 pi. And I could do inches squared. I usually don't like to put units, but then it's that area divided by pi. You'll see the pi's cancel out. And so if you square root 169, you get 13. If you square root inches squared, you get inches, and so the radius is going to be 13 inches. For number 32, we're asked what are the real roots of square root of -16? Well, we can't take the square root of a negative. So even if you tried to take the square root, so the square root of -16 is actually 4i, but since this is not a real number, and then you'd have to go and then root this, but the idea is that this is not real, so there are no real roots when you're square rooting a negative. For number 33, we're asked to find the error in this statement. Well, let's see if there's a problem in the first one. So the numerator seems good. If you have two things, cube roots, that are multiplied, you can put them all under one cube root, so that seems just fine. Now, let's look at the denominator. So here we should have, just like we put both of these things underneath the same index, We should have done that here. So cube root, and there's 2y, so that should be y squared. Aha, so here's the issue. If you multiply a square root by itself, like square root of something by square root of something, yes, you just get whatever's inside. But to get cube root of y times cube root of y, in order to get y, you'd have to multiply by a third cube root of y. So the problem is this right here. It shouldn't be just y, it should be cube root of y squared. And just a reminder, the only way to make that y is if you do cube root of y times cube root of y times cube root of y, that gives you y. In the same way that if you do square root of, let's use the letter p, square root of p times square root of p, it only takes 2 of those to get a p because a square root has an index of 2, so you'll need 2 copies to get what's inside. For y in a cube root, you need 3 copies to get what's inside. Just so you, how many, let's say you have fourth root of, let's do m. How many copies of these would you need to spit out just an m? Well, you need another fourth root of m, another fourth root of m, and then a fourth root of m. Let's multiply 4 fourth roots of m together, which is really fourth root of m to the fourth, to be able to spit out an m. And technically, this would be actually like absolute value of m, technically, but either way, you can get the idea. Or actually, no, it might not be that important to put the absolute values here because these m's are individually out there. So we can assume that it's not negative because if we're allowed to even square root this number, we're assuming that it's not negative. So you really actually don't need the absolute values, but don't stress too much about that. Just know that this is good practice for rationalizing a denominator. If you're rationalizing a square root denominator, you need 2 copies of it. If you're rationalizing a cubic root denominator, you need 3 copies of it to turn it rational. All right, we know that 0 to any power is 0. That makes sense. But what about 0 to a negative power? Well, remember, negative power is what? A negative exponent or a negative power means reciprocal. It does not mean that's this like negative 0. So here's the idea. If you reciprocate, so like x to the negative 1, that's 1 over x. X to the negative 2 is 1 over x squared. It's the reciprocal of x to the second. So what's the reciprocal of 0 to the 2/3? Well, 1 over 0 to the 2/3. We have a problem here. We have a 0 in the denominator. Anytime you divide by 0, your value is undefined. You cannot have a 0 in the denominator. All right, for this one, we're asked that if x and y are integers, explain why the product x plus y and its conjugate will always be an integer. Well, just to show an example, it's because the square root part will always cancel out. So the conjugate of this is x minus square root of y. So no matter what those numbers are, you got square root of y times square root of y is just going to be y. And then, well, we should have some other radical parts. So like this right here is negative x root y. And then this right here, this right here is positive x square root of y. So hey, there's 2 more radical parts, but those parts cancel out. So the idea is that the radicals will always cancel each other. All right, last one. So we're explaining why negative 8 to the 1/2 is not the same as negative 8 to the half, but it is true in cube roots. And here's the reason. The short answer is you can cube root a negative. You can't, remember 1/2 power is a square root. You cannot square root a negative. So the reason is you can't, for the record, you can't fourth root a negative. So even if this was like 1/4 power, you can't take an even root of a negative and get a real number. It's always imaginary. But you can cube root a negative number and still get a real number.